So for chapter 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 learning targets for the whole unit. Most of them are review odd and even functions, rational functions, polynomial functions. You're going to see the pace of things that we've done in the past continue to speed up. So make sure you're doing your homework and following along, and then coming to study groups. So the goals for 3.1, just for this section, is that we're going to define polynomials and we're going to note special features of polynomials. And then goal B is we're going to graph polynomials. And I'm going to teach you guys a cool trick called synthetic substitution. And then we might look at some other little tips and tricks under other techniques. Now, 3.1, polynomial functions. So a polynomial is anything where the power on the x is an integer here. And so we could have x cubed, squared, all the way down to x to the first, and then we have what's called a constant back here. And then the a sub n minus 1, those are just talking about the coefficients of the variable here. So let's look at a few common types. So we have degree 0, which is called the constant function. And an example might be like y equals 5. So if this is 5, we would just have a flat line there, no slope at all at y equals 5. Then we might have a first degree function, which we've looked at in the past as mx plus b, but here we're looking at ax plus b to kind of create a continuous pattern as we look at different polynomials. So this might be y equals 4x plus 7 or something like that. And these are all linear. So maybe something like that. Then we have second degree, ax squared bx plus c, standard form. So maybe 3x squared plus 2x minus 7, something like that. Second degree functions are called quadratic, and they look something like that. These can be shifted up, down, left, right. And then third degree functions are called cubics, and this might be something like y equals 2x cubed plus, we'll make it tricky here, plus 3x minus 2. And if I was going to ask you what the coefficient on the b or the x squared term for this, you would say it's 0 because we didn't write it in here, so it must be 0. And then cubics sort of all have a shape like this. Okay. For each polynomial function, there is a polynomial equation where p of x is equal to 0, solved visually as the roots, that's what we sometimes call those, or the zeros. So this polynomial right here is a cubic, and it has 1, 2, 3 roots that we can see clearly.